The input voltage is 1 volt 30 milliamps. The output is a few thousand volts, I think 2,000 or 3,000 volts. So you can get from only 1 volt a voltage from about 2,000 or 3,000 volts. Now I can increase the voltage from 1 volt input to 3 volt input, and the current is about 60 milliamps. This way I get voltages about, I guess, 6,000 volts from. Here you can see that the input voltage is only 1 volt DC and about 23 milliamps, and the output is an AC about 120 volt alternating voltage. The Arduino code is very simple. I declared an integer Zeit gleich equal 80, and in the setup only pin mode 7 output. In the loop type I have digital write 7 high, delay microseconds Zeit, and digital write 7 low, delay microseconds Zeit. This means the output digital 7 gets 80 microseconds high and 80 microseconds low, then 80 microseconds high and then 80 microseconds low. The time I tested which was best for the highest voltage. In my case I got from 1 volt DC about 120 volt AC, volt alternating voltage. Now I explain how it works. I used a Mosfet. A Mosfet is an electronic switch, and with Mosfet I choose this type from Infineon. Has 3 ports called gate, drain and source. You can connect the source with ground, and when the gate gets from the Arduino a high signal plus 5 volt, the Mosfet is switched on. That means that the resistance between drain and source is nearly 0, and when the Arduino sends the signal low, the Mosfet is closed and the resistance between drain and source is very high. I used a resistor of 100 kilo ohms connected from gate to ground in order to achieve if the signal is low that the Mosfet closes. I don't know if this resistor is necessary or not. I use this because I want, if the output is high, the Mosfet should turn on, and if the output is low, the Mosfet should turn off. You can test if you need it or not. The Arduino sends the signal high for about, in our example, 80 microseconds, and then the signal low about 80 microseconds. This means the Mosfet is closed for 80 microseconds, open for 80 microseconds, closed for 80 microseconds, and so on, because this is in the loop part. Then you can use an external power supply with e.g. 2 volt DC. The current was, in our example, 50 milliamps. You could use a battery with 1.5 volt. You can use a power bank with 5 volt perhaps. And I need a transformer. I bought a transformer in Europe. In Europe we have 22 volt AC in our power grid. The transformer is built to produce from 22 volts from the AC power grid 3 volt AC. But we use this transformer in the opposite case, that the current flows from, if the Mosfet would be closed, the current would flow from the plus 2 volts through the transformer to the Mosfet and then to the minus. If I would have a high delay, e.g. 1 second on, 1 second off, this would mean that I have no circulating voltage. I would have a current for 1 second and then no current for 1 second. But if I use a very high frequency, the frequency in our example was about 6 kilohertz. This means 6,000 hertz. And the result was that when you use this switch with the high frequency, there's a eddy current or induced voltage from this coil. And the result was, you have seen this on the oscilloscope, that the voltage I measured with the oscilloscope here would be about 220 volts and 6 kilohertz. And I think this is quite impressive. I can transform 2 volt DC with about 50 milliamps to nearly 2200 volts AC with 6 kilohertz. And this here is a so-called voltage cascade. The construction is very simple. You only need some capacitors. In my case, I used capacitors with 0.047 microfarad, and you need diodes. The diodes let the current flow only in one direction, here from plus to minus. And this cascade has the effect that you can transform 220 volt AC to e.g. 1244 volt plus. You have then only here the plus, and you can take the ground as minus. Then you have a current between plus and ground from about 1244 volts. And if you use more than with capacitors, you can increase the voltage. I think in our experiment we had voltage about 7,000 volts or so. You can also increase the voltage when you use, instead of 2 volt DC, e.g. 5 volt DC or so, but you have to notice two things. First, the transformer I bought is only for 300 milliamps. That means if I have about 50 milliamps with 2 volts, I think I reach 300 milliamps when I use e.g. 5 or 6 volts, or maybe I can take this 6 times the voltage. Maybe I can also use about 12 volts, and then it is possible to get very huge output voltages. And the second thing you should remember is the voltage for this capacitor. In my case, I built this voltage cascade several years ago for a normal power grid. In Germany we have 220 volts AC, and so I used only a capacitor which is suitable for about 500 volt or AC or so. And this means I am not able to use here 10 or 12 volt, because then the power here would not be 220 volts AC, would be about, I guess, 1000 volts EC, and this is too high for my capacitors. But you can buy perhaps a capacitor which is suitable for AC voltage from 1000 or 2000 volts, then it should be no problem. Other method I mentioned would be to use more diodes and capacitors to increase the voltage cascade. I used a Mosfet. Mosfet is an electronic switch. You can switch with a very high frequency, with 3 connectors: gate, drain and source. The source is connected with ground, and the gate is connected with the Arduino D7 output. And the result is when the output of the Arduino is set high, the resistance between drain and source is nearly zero, only 8 milliohms, and when the output of D7 from the Arduino is low, the resistance between drain and source is much higher. Then I use a transformer. I used it from 230 volt input and the output is 3 volt. Normally you connect these pins with a power grid. In Germany we have 230 volt AC and you get an output from 3 volt AC. And the maximum current for this is about 300 milliamps. But we use this in the opposite way. We take the input here, e.g. later with 1, 2, 3 volts DC. We switch it with a Mosfet on and off, so we get a very high frequency and the current is not so high. When we used 1 volt DC, the current was less than 30 milliamps, and we used 3 volt, the current was about, let's say, 70 milliamps or so, also much less than the 300 milliamps I could use. This is the way my voltage cascade looks. It consists of several capacitors and diodes. I show you a diagram how this works, and I built it several years ago, and I used it to connect it direct to a power grid with 220 volts AC, but in my experiment today I used it with only 1 volt DC and transformed the 1 volt DC with the Arduino and the transformer to about 120 volt AC, and then with this power cascade about 2000 volt DC. And I could have used more than 1 volt, e.g. 3 volts, but the capacitors I used here are originally for the power grid with 220 volts. If I had other capacitors which were suitable for higher voltages, I could have used instead of 3 volt, e.g. 5 volts, and on this way I could have reached output voltages about, I guess, 10,000 volt DC.